Hi, Rajendra here. Today we are going to discuss about a chi-square test. Why I haven't taken this example because many of you are doing research and many of my students were asked to do a video on that. Okay, how to perform a chi-square test. One of the students shared his data. Okay, like collected a data on a SBI customers from the SBI customers, their satisfaction towards the SBI performance, service performance, with a different perspective. He has been used around more than 15-20 questions. He has been used to get to know about how they are like performance, like a service performance. Okay, to do this one, the first thing we have to understand how to do a chi-square test. Why we are using a chi-square test? Here I use a chi-square test because I just want to know that whether two questions are dependent on each other or not, like the kind of reactions are dependent on each other or not. For example, here I will take one example I can give. Here one question I will pick up, that is a SBI performance the service quickly, like the quickness of the service. Is it depends upon, I just want to check with the in-time service. Okay, employees in-time service, like time management from the employees. Okay, SBI employees, is they are dependent to each other or not. Okay, to check this one, how to do this one, we can use a chi-square test. Okay, whether these two reactions are dependent on each other or not. To do that one, first we have to construct a null hypothesis and alternate hypothesis. Then we will try to use a chi-square test. The steps I will show, these are the steps we have to perform. How to do that one? First I will select the entire data, select entire data. Okay, then go to insert and pivot table and insert a pivot table. Once we inserted a pivot table, the which are the two questions we are analyzing, we'll take for that. Okay, question number Z. Yeah, that is nothing but a SBI performance service quickly. Is it true? And one more question I will take. That is nothing but a one I taken in a row wise. One more I will take it in a column wise. So cross table will be done. Is it employee, right? I haven't taken, yeah, that time management. So, and to get the count, that like who said one for yes, their service is very quick, and as well as given a one rating, like lowest rating for like they are not managing a time. Both reaction given, how many are there, like that we can count by using this name. If I take it to value, so it will count how many are there. Such reactions have been given for both the questions. Okay, once I have been done with this, now I will construct a null hypothesis. Okay, your null hypothesis will be null null hypothesis will be like, is they are independent to each other. Okay, these two questions are independent to each other. That is nothing but SBI service quickness is independent to uh, service quickness and employees time management are independent to each other, right? There is a null hypothesis. Alternate will be the same thing. Okay, alternate hypothesis will be same, but we say dependent to each other. Okay, they are dependent to each other. Okay, they both are dependent to each other. How to perform that? First, what I will do, I will copy this entire table, copy and paste special, so that right click and select paste special and values, so that that particular thing has been copied and pasted. Row wise we know that This is nothing but a quickness, employee quickness, reaction. This is nothing but a the column wise which we have 1 to 5, that is nothing but a employees time management. Okay, and total for the row wise and column wise we have. Now this is nothing but this table is called as a observed table. Okay, in chi-square test it is called as a observed values. Okay, observed values. Okay, for example I will just give a different color so that it will be very easy to recognize. Okay, this grand totals I will take it in a other color like green, so you can distinguish easy. The center one is nothing but the which is there in a white color, that is nothing but the observed value. Wherever you are not finding a value, just replace with a zero. That is nothing but there is no one has given that reaction. Okay, replace with the zero. Once you have been done with this, next step is to calculate a expected value. Select this observed value table, copy that, paste it somewhere, and I will change it to expected values. Okay, this is nothing but expected values. Here, how to calculate expected values? The middle one we will delete. I will delete all the values here, and we have to take a total, so equal to sum of all this will be grand total for each column wise. Similarly, row wise equal to sum. Select this row data so that row wise total we got. Right, now how to calculate the expected value? Expected value is nothing but expected value formula is nothing but row total. Okay, row total multiply by column total divided by grand total. Right, okay, to be precise, the grand total is nothing but 77. That is the number of observants you have. Okay, this which red color one. Okay, that is a grand total. For the first observation, row total will be this one. Okay, for first observation, row total will be this one, and column total will be 5. Okay, 5 multiplied by 5 divided by 77 we have to do for the row total. Similarly, for the second observation, the row total will be same, like it will be 5 only because this observation. Okay, and this one will be column total will be 6. 5 multiplied by 6 divided by 77. Like this we have to do. How to do it quickly? By using a cell referencing, like row total I will take, and this column should not change. For that reason I'm fixing a column O multiply by row total, column total. In this column total, this row should be fixed, so row we will use a dollar symbol to 10, and divided by total. Okay, every time it has to be divided by same total, so I'm fixing entire value. Okay, function F4 key. It will calculate. When you are drag it down, if you are getting same row total, means your calculation is correct. Okay, when you are getting the same grand total and these totals are matching with your observed value, then the calculation is correct. If you've done any mistake in a calculation, then you will not get this grand totals. Okay, the sum of these values will not match with the original value, observed value. Once you have been done with this, like expected value and observed value, now it is time to calculate a chi-square. Okay, chi-square. The chi-square value will be nothing but the sum of O minus E. O means this one observed value minus expected value. We will take a whole square of that divided by E. This will be taken. Then we will sum that one. Okay. So first what we have to do? We have to take a sum of O minus E. Okay, whole square to the power of 2. Okay, we will square that divided by E. Okay, this term we will calculate and we will take a total of that. Okay, how to get that chi-square table? Again, select this one, copy, paste somewhere, Okay. uh, Delete this one. We are not required to calculate anything like this. Okay, only we will be required to calculate this much. Okay, then we have to take a total. Okay, that is nothing but is equal to O minus E, right? O minus E means the observed value, the first one, 1 1 combination, 1 1 combination observed value, minus for a 1 1 combination expected value. Then we have to take a square this one. How to square in a Excel? I will use a power formula to square that one. Okay, so power comma power of 2, so that it will be squared. So this difference has been squared. Now we have to divide that difference, square difference, by the expected value, so that we will get a total value. Now if you drag it to the right and down, you will be calculated for the all of them. Okay, you will be calculated for the all of them. Then what we have to do, we have to take a sum of all this calculation, that is nothing but chi-square value. Okay, chi-square values. Okay, when you take a total chi-square value, this is nothing but a calculated chi-square. So here, when you come to the interpretation, first we have to take a calculated chi-square. Okay, how much it is? Calculated chi-square is about 84.67, right? 84.67, 84.67. Okay, this is a calculated chi-square we have 84.67. That is a calculated chi-square value we have. Now I will take a critical chi-square value. How to get the critical chi-square value? Critical chi-square value will be calculated based on a degree of freedom and level of significance. When you are before going to the hypothesis testing, we will be decide with the level of significance. I will decide by 5%. Okay, 5% level of significance I will be decided. And how to calculate the degree of freedom? The degree of freedom is nothing but the number of entries row wise. That is nothing but a m value. Okay, I will take row categories. Okay, row categories, that is nothing but 5 categories we have. Okay, row categories can be designated as a m. Okay, then column categories, that is I will take designated as a n. Again here, total number of column categories 5 we have, so 5. So degree of freedom will be m minus 1. Okay, into n minus 1. Okay, this is the formula for the degree of freedom. So how much it will be then? M minus 1 is nothing but 4 into 4, right? 4 into 4, because 5 minus 1 into 5 minus 1, that is 4 into 4, for a 60 degree of freedom. Okay, 16 degree of freedom and 5% level of significance. What would be the critical value? We have to check that one. How to get the critical value? We have a chi-square table. If you google it also, you will get this one. Okay, chi-square critical value for the chi-square distribution with a degree of freedom. Here we have to check for the 16 degree of freedom. Here there is a 16 degree of freedom. For a 5%, the 0.05 means 5% level of significance. If you have a 10%, you can select this one. If you have 1% level of significance, you can select this one. I have 5% level of significance, so 26.296. Okay, 26.296, that is the critical value we have. So we will take this one, 26.296. 26.296, that is nothing but a critical value. The conclusion here is, we can come to a conclusion by comparing a calculated value with the critical value. when calculated value is higher than critical value, then reject null hypothesis. Okay, rejecting a null hypothesis. So here calculated value is about 84, that is higher than the critical value, right? Critical value is about 26, but your calculated value is about 84, so it is higher than the critical value, so we have to reject the null hypothesis. That is nothing but they are not independent to each other, they are dependent to each other because of employees maintaining their time management help to give a service quickly. Okay, SPI will service quickly because of their employees time management. Okay, this is what we have been arrived to the conclusion by doing this hypothesis testing. Okay, just go through this step by step. Okay, if you have any doubts you can comment it. Okay, this is how we will conduct a chi-square test for a given any given sample. Okay, here we have all the sample. You can take any other questions also, like whichever the questions you would like to relate them, is there dependent to each other or not. To check that independency or dependency, to check that one, we will be conducting a chi-square test like this. Okay, thank you.